Let's work an application problem involving finding an angle in radian measure, and the angle is part of the geometric figure that's shown to you to the left. And you have two triangles. One is a right triangle OAC, and on top of the hypotenuse OC is another triangle placed at a right angle at C, OCB. Okay, so I have two right triangles here. And what I know is that the angle AOB is the large angle here. Okay, I'm going to call that guy theta. Since I know how to work with right triangles, I can note that angle AOC is some measure beta, while angle OCB may be some measure alpha. Okay, you can take your choice of how you label these. And what I know about triangle OAC is that OA is 17 and AC is 12, and the angle beta, we have enough information to say that the tangent of beta is 12 divided by 17. So we have enough information to say that beta is the arctangent of 12/17, and this would be in radians. Okay, so we know this. For the other triangle, OCB, we know that BC is 12. We know the angle alpha is adjacent to OC and opposite BC, and if we had either OC or OB, we could find a trig function value for alpha. So go back and notice in the triangle that OC is a shared side between the two right triangles, and OC is the hypotenuse of OAC, and therefore the Pythagorean theorem can give us this value. Okay, so we have actually the value of OC. Now you could leave the value unsimplified if you wanted to, since you have access to a calc pad in this problem. Okay, but what we know is now the tangent of alpha is 12 divided by the square root of 433. Now where are we going with this? Well, alpha is also an angle that's acute, so we can confidently say alpha is the arctangent of 12 divided by the square root of 433. And what does this have to do with the angle that we're trying to find? This guy, theta. Well, I want you to note that in the figure, the guy we want, which is angle AOB, is actually beta plus alpha. Okay, so angle AOB in radians is actually the arctan of 12/17 plus the arctan of 12 divided by root 433, and the default for webasine is radians for arctan, arcsine, arccosine. Okay, so we're good to go.